we ended up having shortages of energy when I was a kid that I remembered that caused real hardship in my town. And that was one of the reasons I vowed to do something about energy.
My group in particular is very proud to be working on some sustainability pursuits. We work on energy storage. That's one of our research thrusts. Anything from developing better electrolytes for batteries to solid-state batteries.
Current battery technology isn't ideal for applications which are becoming more important in future society, such as electric vehicles or grid-scale energy storage. The hope would be to develop a new battery chemistry that is more ideal or more suited to these applications. Right now I'm investigating solid-state ion conductors for divalent ions. And essentially this would be the first step in creating an all-solid-state zinc or all-solid-state magnesium battery, which would be cheaper because magnesium and zinc are more abundant than lithium. It would be safer because you're not using a flammable liquid electrolyte. And then it can also potentially store more energy than current battery technology.
I serve as director for a Department of Energy center called the Liquid Sunlight Alliance. We call it LISA, affectionately. And LISA is a partnership led by Caltech with a missionary objective on creating liquid fuels and chemicals from sunlight and carbon dioxide. So LISA is taking a new approach to expand the range of products that we can make that will include, for example, fuel that can fly airplanes that doesn't come from fossil fuels. By creating a process where we can harness CO2 from concentrated sources where it's emitted and also from dilute sources, we could actually close this cycle and make use of carbon-based energy a zero carbon, net carbon emitting option.
My research involves designing new catalysts and using solar energy to transform carbon dioxide into more valuable fuels. So the chemical industry typically uses very high temperatures and pressures to run their reactions to produce valuable fuels. However, here at Caltech, we're trying to develop new ways to drive these reactions at lower and more mild conditions using solar energy or other new catalysts. So in our modular compression cell, we can interchange different catalysts and different reaction gases and test different reactions under different conditions.
In the area of energy, light is essentially our most abundant energy source. One of the places where the sun shines all the time is in space. So the premise of the Space Solar Power Project is that with an advance in technology that could make photovoltaics less dense, lighter in a mass per unit area metric, we could deploy photovoltaics at a very large scale in space in a way that would allow continuous energy generation 24 hours a day. So the Space Solar Power Project is bringing together ultralight photovoltaics together with wireless power transfer that can beam power to the Earth's surface. And so in a very interesting and interdisciplinary project here at Caltech that involves applied physicists, aeronautical engineers, and electrical engineers, we're bringing together all of these into one monolithic deployable structure that could harness and generate energy in space at a large scale.